Now, let's go to the naming of the carbon compounds. Now, for the naming of the carbon compounds, we are according to the rule or the system called IUPAC. Now, IUPAC stands for the International Union of Pure and Applied Chemistry. So why we say that this is a systematic name? Because there are some rules that we have. First of all, we start with the alkanes. Naming of alkanes by the IUPAC system, first of all, we just need to know how to name the straight chain alkanes first. Now, we have a term called prefix and suffix. The suffix is the name ending parts. So it should be ending with the word the alphabets of A, N, E, because you are in the alkanes group. So the suffix, the ending part of the name will be A, N, E. While straight chain of alkanes are named according to the number of carbons, that is here. If it has one carbon, Me, two carbon, E, and then we end up with ANE. So the whole words will be methane, ethane, if it contains two carbons there. So for alkanes, we didn't contain any functional group. It just contains CC single bond and then CH bond. So that will be CH3 with a single bond between carbon and carbon bonds. While 3 carbons, propane, 4 carbons, butane, this is named as bute. 5 carbons inside the carbon chain, pentane, 6 carbon, hexane, 7 carbons, heptane, 8 carbons, octane. Now, starting with 5, 6, 7, 8. Now, 5, we can know that pentagon means there should be 5 sides. So pentane with the word pent. So carbon 5 has hexagon, hexane. We end up with ANE. Heptane, octane is corresponding to 5 to 8. While the 9th and 10th carbon, in fact, it is out of syllabus. But just let you know, if we have 9 carbon non-name, while 10 carbon, this is decane. So these are the naming of the alkanes with the straight chain one. Now, for details, you may refer to the nomenclature of organic compounds, and then there will be some websites providing you more information. Well, next one about the branching. Now, if we have a straight chain, easy for us to talk about with is methane and butane. How about if there is branching? That means they are no longer as a CH4. Instead, it's eliminating as a H, and then attaching to the carbon. Then this is no longer a methane. We say that this is a substituent. We substitute the hydrogen atoms with the methyl group. This is called methyl group because it contains 1 carbon there. Well, just the same case, if we have originally a butane here, we eliminate an hydrogen and then substitute to the long carbon chain, then it will be a branched. So this branch, again, it is a substituent. So we say that this is butyl group as a substituent. Now, please observe that the change, in fact, is just changing with ANE to the YL, methane to becomes methyl. So methyl group or butyl group as substituents. The alkyl groups divide from alkanes by removing a hydrogen atoms, then substitute into the hydrocarbon chain. We may simply represent this by the symbol of R and then dash there. So the name by replacing the suffix ANE of the parent to becomes YL. So it is no longer alkane, it is alkyl group. So as a result, for example, methane, we eliminate the ANE and then we replaced the YL. That will be methyl group. So methane, if we change to becomes alkyl group as a substituent, it will be methyl. Ethane becomes ethyl, propyl, and butyl correspondingly. So naming of the branched chain alkanes. Named by considering them as a straight chain alkanes with 1 or more hydrogen atoms first by replacing by the alkyl groups. The systematic names should be having two parts. One is about the prefix before the name. The prefix will be indicate that the alkyl group substituents. So that means in front of the name, we have a prefix. The prefix is the branched one, which is the alkyl group. The root then will remains for the indicates the main carbon chain then. So that's why we have two parts. One is the root and other one is the prefix. So for the basic IUPAC rules for naming the branch chain should be, first of all, we need to find out the longest carbon chain first. So the longest carbon chain here, we contains 5 carbons. So a pentane with one substituent. Because we have 5 carbon, it should be pentane. Without any CC double bond, it just contains CC single bond and CH bond. So this is pentane. And then with a substituent, so the root would be pentane. While the longest continuous carbon chain need not appear to be the straight line on the paper. For example, it can turn around. Because this is chain means it can turn around. So if it is just a straight line, then it should be involving 5 carbons. However, when you take a look for this one, it should contain 6 carbons at all. So these 6 carbons will form a hexane as the longest carbon chain. So we need to recognize the alkyl group, number the carbon atoms 1, 2, 3 in the chosen main chain, starting from the end so that it will give the lowest possible numerical numbers. So here, for example, this is the longest carbon chain. We can assign it according to the right-hand side to the left-hand side from 1 to 5 accordingly. Then the methyl group, the substituents will be labeled as 4. But at another side, we can label it here. So starting with 1, 2, 3, 4, 5, from left to right. Then the methyl group will be on the second carbon. So we need to starting from the left-hand side so that the alkyl group is attached to the carbon that is starting with carbon 2, because this one will be having a lower number. So the next one, naming the alkyl group, indicates its position by adding a numerical numbers there, followed by a hyphen in front of the name. That means we have the parent or the root, it is pentane, while it consists of a substituent, which is methyl. And then we have to label the position, that is 2. Like in between the numbers and the alphabets, we should have a hyphen. As a result, 2-methyl pentane. So what we call the 2-methyl is a prefix, while the pentane is the parent chain or the root. So it is necessary to remember that if the position of the alkyl group is very, very obvious, then we don't need to assign any number on it. For example, for this one, we will not say 2-methylpropane because it is obviously, it is at the second position. It cannot be going to the next one. The methyl group cannot be the first carbon, cannot be the third carbon, because if it is first or third carbon, the name will be butane. So the only branched position must be at the second carbon. So the obvious stuff, we don't need to mention about 2. And if 2 or more of the same alkyl group are present, then group them together. We need to group them together and then name them with a multiplying prefix. So the multiplying prefix, for example, if there is 2 alkyl group, identical one, 2 identical alkyl group, for example, 2-methyl group coexist, then we will add a multiplying prefix, that is di. So we will have dimethyl. Or if we have 3 identical alkyl group, then it will be triethyl, 4 tetraethyl or 5 pentaethyl. So write down all the numerals of the attaching carbon atoms, then separating them by the commas. For example, for this one, a very, very long carbon chain, and then we have to choose which one will be the the numbers, the numbering. Like if we count it from left to right, the first substituent will be starting at 3. While if we counting on the right-hand side, you will find that the substituents will be starting at the second carbon. So according to this rule, when more than one substituent is present, the main carbon chain is numbered from the end closest to the first substituents. That is from the right-hand side to count as 1, but not the left-hand side one, because the first substituent is encountered at the second carbon. So in the following example, 2 methyl groups are present. So that's why we say that this is 2,3-dimethyl, because both of them are identical. And then we say that they are methyl group. So it is dimethyl. And then at the second and the third carbon position, it has the methyl group. So it is 2,3, 2,3 dimethyl pentane. Remember the numbers and numbers in between them, we will use a comma. While the numbers and alphabets, then we will use a hyphen instead. So these are more examples here. We will have 2-methyl pentane because at the second carbon, we have the methyl group. And then this is 3-methyl pentane because we have the third carbon, we have the methyl group. And then this one is again, go back to 2-methyl pentane because the carbon chain can be starting with the right-hand side one to count as 1. So in fact, the third one and the first one are the same. Then the following one, this one is the pentane as the longest carbon chain as well. And then at the second carbon and third carbon, we have methyl group. So we need to multiply, give a multiply functional groups there, dimethyl. So this will be 2,3-dimethyl butane. The lower one, it will be 2,2. The second carbon have 2 methyl groups, so 2,2-dimethyl butane. If we eliminate one, so this one is in fact methyl butane, because the methyl group must be present on the second carbon, but not having the third one. So we don't have 3-methyl butane because if it is 3, that means here, then we can count it off from the left-hand side to the right-hand side. This is also true as well. So we just have one kind of methyl butane. So if there are different alkyl groups, like the previous one, we have talking about identical alkyl group. Both of them are the methyl. But if we have different alkyl groups, so we arrange them in alphabetical order. So for example, if we have both methyl or ethyl, no matter it is dimethyl, trimethyl, or tetramethyl, we just consider about M, because M is representing the methyl group. So no matter di, tri, or tetra, we just need to take a look for the M, compare with the other alkyl group and other different alkyl groups. So it is ethyl group, then ethyl or ethyl, E. So we'll be going first, because we need to follow the alphabetical order. So we need to name ethyl first. As a result for that, the name for this compound should be 3-ethyl 2,4-dimethyl hexane. Now, although 2 is a smaller number, we are not according to the numerical value. We are talking about the alphabetical order, E and then M. So we don't need to take a look for di, tri, or tetra. We just need to take a look for the substituent groups. This is ethyl group and the methyl group. As a result, it is 3-ethyl 2,4-dimethyl hexane. So at the second position and the fourth position, we have the methyl group. So this is dimethyl. And then the longest carbon chain is 6 carbons there. So as a result, we say that this is 2,4-dimethylhexane. So we have the main root or the parent chain hexane. And then we have a prefix. The prefix, don't forget the numbers and words should be separated with the hyphen. And then the words and number, again, it should be a hyphen. Then numbers and numbers, we should have a comma to separate it. So the wordings, they always stick together as one word, but not separate to two words. Do not take away the prefix and then separate it to becomes another word. It should be sticking to the roots here. So this is the short summary. And then you may now try the page 6 classwork 1 by yourself now.